right, now our first problem on the notes here, we've got 5 different parts to this question. So the very first thing says to write an equation for the line. Now writing an equation for the line, we know we're going to use slope-intercept form, which is y equals mx plus b. And in place of that m, we need to put the slope. So I can see from my two perfect points, one here and one here, that my slope is up 1 unit, and to the right 2 units. 1 up to the right 2 units. So my slope is 1/2. So in place of m, I'm going to write 1/2. And then b is my y-intercept when I have slope-intercept form, and I can see that my line crosses over the y-axis there at 2, which means that my slope-intercept is 2. So my b is going to be replaced with plus 2. So the equation of this line is y equals 1/2 x plus 2. Now the next question says I need to find the slope of a parallel line to that one. So a parallel line I know is going to be a line that does not ever touch that line. It's going to be at the same angle. It's going to be something along the lines of that. And it's going to go on and on forever in both directions. And now that line right there, since it's at the same angle, I know it's going to have the same slope as the one before. So I know the slope of a parallel line is going to be 1/2. Now I need to find the equation of a line that is parallel and goes through the point 1, -1. Now in order to find that line, I need to use my slope-intercept form and substitute in my point. So I have slope-intercept form. My slope-intercept form is y equals 1/2 x plus 2. That was my original equation. Now I've got a different equation this time. My second line is not necessarily going to be a y-intercept of 2. In fact, I want to make sure that it's going to intersect to the point 1 and -1, which means it's going to go through that point right there. Now, in order to find the equation of that line, I need to find out where does that cross my y-axis. And in order to figure that out, I'm going to have to say, all right, well, I don't know the y-intercept, which means I'm going to just use my variable still. So my variable for the y-intercept was b. And now I'm going to substitute in my point. So in place of my x and y, I'm going to substitute and get rid of the x and the y, and I'm going to substitute in my coordinate point that I have here. My coordinate point is 1, -1, where -1 is my y value and 1 is my x value. And now I just have to solve for b. So I have -1 is equal to 1/2 times 1, which is just 1/2, plus b. Now in order to isolate b and get b by itself, I'm going to subtract 1/2 from both sides, and -1/2 on that side, which means that b equals -3/2, or -1/1/2 is equal to b. So now I remember that my parallel line has a slope of 1/2. Now I can see that my slope, or that my y-intercept is -3/2. So I can write an equation now for that line. Y equals mx plus b. M is 1/2. My x is my input, plus my y-intercept, which is -3/2. Or we could write that as y equals 1/2 x minus 3/2. Either one would be correct. All right, up next, I need to find out the slope of a perpendicular line. So I remember from before that my perpendicular line is going to take my slope. So my original slope was 1/2. And I'm going to do the additive and multiplicative inverse. So I'm going to first take the reciprocal of 1/2. The reciprocal of 1/2 is 2/1. And then the additive inverse is negative 2 over 1. So that means my slope is going to be equal to negative 2. Now I can see that that's going to be correct by, I can just take some random perfect point here and draw a line with a slope of negative 2 that goes through that. And I can see that that is indeed a perpendicular line. It crosses over at a right angle. So that means that I know that I've got the right slope here. So that means my slope is going to be negative 2. So just like in my last one, I've got to write an equation for a line. This line is going to be perpendicular, which means I'm going to have a slope of negative 2. And it's going to go through the point 4, 2. So that point is right here on the graph. So I need to figure out what that line is going to be. So I'm going to once again use my slope-intercept form. Same formula that we use for a lot of this stuff when we're graphing. Y equals mx plus b. My m, I already know that my slope is going to be negative 2. And now I just need to substitute my x and my y, just like I did in my last part. So I'm going to take x, and in place of x, I'm going to put my 4, which is my x value, so negative 2 times 4. And then in place of my y, I'm going to put that output, that y value from that coordinate point, which is, of course, 2. So let's go ahead and put that in. So 2 equals negative 4, or negative 2 times 4 plus b. 2 is equal to negative 8. We'll just simplify that down a little bit. Negative 8 plus b. So then we just solve for b. We solve for b. We want to isolate our variable. In order to get rid of that 8, we need to add 8 to both sides. Negative 8 and positive 8 cancel out. We're left with b equals 10. So now just like in slope-intercept form, we have y equals mx plus b. Our m, our slope, we already found out was negative 2. And then our b value, which is our y-intercept, we just found that out is positive 10. So we have y equals negative 2x plus 10.